Alright, this will be the review sheet number 7, quick video, so they're getting a little bit harder and harder with each one we've had now. This first one, Jason Velasquez buys 2 types of flowers, 42 red roses and 56 identical or white lilies. He combines all of the flowers to make identical bouquets for all of his girlfriends. If each girl gets one bouquet, how many girlfriends does he have? So right now we have to look at this and we have to see, right there's your key word. Now if you don't know what that is, it is a, whoops, not a very good letter there. It is a group of flowers. Now I specifically used the word group here so that you would realize that this goes right back to chapter 1, learning target number 9, I think. Yeah, it's 9. Okay, we're trying to break these things into groups. Okay, so there's your little key there. Okay, so you have to think about what would be. We want to know how many total girlfriends he has. The maximum, there's another word for you, maximum number of groups that he can have. Okay, there's a word list on Learning Target 9 in your Chapter 1 notes that help you to identify whenever you see groups. Okay, what that's going to be. And then from there, like if, well, I think you guys will figure this out from there because once you figure out how many groups there are, and if you know he has 42 red roses, for instance, let's say that you could make, this is not the right answer, so I'm just giving you an example. Let's say that the answer was 6. He can make 6 bouquets, which means he has 6 girlfriends. So your answer here would be 6, but that's incorrect. So you guys know, I'm just giving an example. Okay? In order to figure out how many roses are going to be in each bouquet, we're going to take that 42 and we are going to divide by the 6 because the 6 is the amount of bouquets he has. So that's the amount of groups. So you got to think 1, 2, 3, 4, 5, 6. That's how many groups of flowers he has. If he has 42 of those total roses, that would mean 42 divided by 6 would be 7. He'd put 7 roses in each one. 7 roses, 7 roses, 7 roses. Okay? So the answer is not 6 here, which makes this the answer not 7 here, but I just want you guys to understand that that's kind of what you're doing. Okay? These. Okay? I'm going to give you, you have to use your little key down here. Okay? Now there's a way that I teach this that I'm not going to do right now, but when we get to chapter 6, chapter 5, this is one of these front-loaded things when we're teaching you something in the future. When we get to chapter 5, I'm going to teach you how to do this, and it's going to be a lot easier. But for now, you just got to think about it. Okay? So if I know that there are 3 feet in 1 yard, what you need to realize is you're either going to be doing 180 times 3 or you're going to be doing 180 divided by 3. So you got to think about it. If there are 3, if you think about it like this, like 1 yard becoming 3 feet, if you thought about it like that, you'd say, okay, I'm multiplying my number of yards by 3. Well, then that'll be the same thing you have to do here, and that'll give you the feet. Okay, same with tons there. That capital T stands for tons. Okay, if I know that 1 ton is 2,000 pounds, then you'll have to multiply by 2,000 to figure out how many pounds that is for 3 tons, and so on. So just use that key down there to help you out on those ones. Okay. A red flashlight flashes every 32 minutes. A blue flashlight flashes every 24 minutes. When will the 2 lights flash together? Again, there's a key word. I'll write this word over here for you too that kind of makes it easier for you, I hope. This is also chapter 1, learning target number 9 down here. Okay, so you can look back to this to see. Obviously, you're going to need work here. You obviously need to work up here. Okay, so the big key here is, though, notice what the question is asking. It's not asking for what the answer is. It's looking for the answer when. When will the 2 lights flash together again? So if they both flash at 10, you're going to have to calculate and figure out the time. Okay? We did a question just like this on the test. It was about a couple people that were reading chapters in a book. You can look back to your chapter 1 test, your chapter 1 summative assessment, chapter 1 summative assessment, and I think it was number 5. Right on the front, there's one just like this one. You'll see it. It's, if this is your page right here, and you have that line going down, it's the question that's right there. The first one in the top right. So you can look back to that for a little bit of guidance there. Okay. Kroger is advertising a sale on Mountain Dews. Okay. Their advertisement says you can get 6 for $3.96. Okay, so let me give you a good example here. Let's say that they got that. I'll do cereal question. So we got cereal over here. So we have this cereal. We know that the cereal costs $2.50 for 5 boxes. Okay. If I were going to figure out the unit rate, which is what that word is right there, okay, that's just how much one Mountain Dew costs. So for my example, I'm going to figure out how much one box of cereal costs. I'm going to do $2.50, and I'm going to divide it by the 5 boxes. Okay, that's going to give me 0.50, which I know would be 50 cents per box. So my answer would be 50 cents per box. That's how much I'm paying. That's the unit rate, or what's called the unit price. We'll talk about all this in Chapter 5 in December. This will be December. We'll be talking about that then. Okay. Well, if I know that one box of cereal is costing 50 cents, and I want to know how much it costs for 9 of them, 9 boxes of cereal, I'm just going to do 9 times 50 cents. Okay. So remember, whenever you're finding unit rate, and again, we're going to learn this a little different and come December, but there's no sense in me trying to explain to you my method now. But in December, we'll do it a little different. But just understand, you're going to take the amount of money you're spending, the total money, and you're going to divide by the amount of boxes there are. Okay? And that's where we get 50 cents per box of cereal. Okay? And then once you figure out the price for one of them, then you could, if you wanted to buy 20 boxes, you'd multiply 20 times 50 cents. Okay? This one, here's your keyword here. Said it a lot this year. Whenever you see the word cover, we're talking about area. Okay? Just once again, if you need to know the formula, you could look that up to figure out what the area formula for a rectangle. Okay? And this is a rectangular carpet, so I'm going to go ahead and draw it for you because I always think it helps to draw it. This is going to be 16 feet by 11 feet. Okay? And you're going to have to figure out the area. Just remember, I'm going to just put this right here because I was counting off last week for you not using labels. You must use the correct labels. And then for perimeter, guys, down here, when you're finding the perimeter of it, if you need to look it up, you can look it up. It was on last week's review sheet, so you can look at that. Okay, but you definitely need to be able to have your labels on both of these. They got to have labels on both. Okay, here, these are numeric expressions because they only have numbers and operations. Numbers and operations. An algebraic expression would be something like 2 plus b plus c times 9 or something like that. Okay, that would be an algebraic because it has variables in there. These are just numerics. You need to show your work. And it's driving me crazy that some of you are choosing to just jam it into this small area. The whole back page of your review sheet is blank, guys. So use it. Okay, the whole back side is blank, so let's please take advantage of that. Okay? So this one, you'll have to write your PEMDAS. You'll have to follow the order of operations and all that, doing one step. This should have 3 lines when it's all said and done. 3 lines. If you don't have 3 lines written, when I say 3, I mean this. So you'd have that one, that one, that one, that one. That's 3, and then you'd have your answer. Okay, that's the way it should be done. Okay? Your 3 lines are number 1, number 2, number 3. This is just the original problem. This one down here, again, I better see this on a separate sheet of paper. Guys, this is an algebraic expression. Okay? A lot of you are going to miss this week, and here's why. When you look at this, first of all, you got to write PEMDAS. Okay? Like I said, I would prefer you do it on a separate sheet, but I'm going to show it right here just because I got some more room than you guys do. Okay? We need to, every time we're given an algebraic, the very first step we need to do is we need to turn that into a numeric expression. So that means I'm going to leave the 4 because it's already numeric, 4. When a number is touching a variable, it means multiply. So times b, so what is b? Well, it equals 3. Then the exponent goes on that. Okay? And then it's going to be plus the absolute value of negative 7. There we go. So there's our problem. Now we're going to write PEMDAS, which I'll write over here again. I already wrote it, I think, but that's that. Guys, this is absolute value, as you guys remember from Chapter 2. Okay? We're going to treat those as parentheses. So we're just going to go ahead and take care of that very first thing. So we're going to go do that, and then we would rewrite, and then go there. Now I'm not going to go any farther, but this one's going to have, if this is the first line, it's going to have 3 more lines after it. Okay, so you must have it so it looks like a tornado and all that. Okay? All right. Okay. This one would be chapter 2 stuff here that we've talked about quite a bit. We did these on your test. We've done them in the notes. We've done them on the worksheet. We did them on that long 2-hour long video that okay, we've done these a lot, okay? So if you need any help with this, you just need to work on it. It gives you the fake sun, it gives you the birds, it gives you the sea level, it gives you the giant jellyfish down here. You just have to figure out how far apart they are, okay? Just remember, when they're on the same side, we subtract. When they're going across 0, we add. Okay? So I don't think we need much assistance on that. These, guys, biggest thing here, biggest advice I would give you is to do a number line. Okay? Or look up a number line to look at. Okay? The first one here, I know that if I were numbering a number line, it would be 0, -1, -2, -3, -4, -5. Extend this number line out a little bit. Okay? -6. And that's how we count negatives, going from right to left, just like we would going positives left to right. So when I look at this, I see that -3 is here, -7 is here. Since -3 is on the right, I'm always going to be trying to eat the one that's farthest to the right. So it has to be like that. Even though the sign is flipped, as you can see, if I put teeth on there, I'm trying to eat the -3 regardless. Okay, because it's farther to the right on the number line. Everybody got that? So it's always going to try to eat the one that's farther to the right. Okay, this one would require some work here. Maybe. They do have common denominators. I would probably say turn them to decimals if you want to. But definitely use number lines to help you out on that one. Okay. An outlier. Okay, I'm going to tell you what an outlier is because this is new. An outlier is a number that doesn't belong. So I'll write that. A number that doesn't belong or doesn't fit in, or it doesn't look like the rest. A number that doesn't fit in or belong. Okay, that's what an outlier is. So up here we have a 15-year-old, a 17-year-old, a 16-year-old, a 35-year-old, an 18-year-old, and a 16-year-old. Which one of those, in this dance class, which one of those would be like considered not fitting in with the rest? And obviously that's going to give you your answer. Now, when you get down here, you're going to be finding the mean age, which is just the mean. Now, just a quick refresher of the mean, that is the one that you are going to add up all the ages. In this case, we're going to add them all up, get a total. Right here will be your total ages, like 15 plus 17 plus 16 plus 35. Okay? Then we're going to divide it by however many people there were, how many numbers there were. So that's how you find mean. Okay? Now, what's confusing about this is I'm going to highlight a couple things. This says what is the mean age with the outlier. So that means you're going to include this outlier that I didn't tell you what the answer was, but you're going to include it in your mean. In the one below this, you are going to eliminate the outlier. You're going to take it out. So you're going to have one less person in that grade that's going to help you, and then you're going to add up the ages and divide by one less person. Okay? Change in temperature. Guys, this is absolutely I would want you to use a thermometer question here, or use a thermometer because, I mean, I just think it makes it easy. Like this first one, -32 to 15. Well, if I know 0's there, -32 would be down here somewhere. 15 would be up here somewhere. If I'm figuring out the change in temperature, I know it would have to go up 32 degrees just to get back to 0. Then it would have to go up another 15 to get up to 15 degrees. We've got to add those because we went across 0. So that would give us 47 degrees. So I gave you the first one there. So no work there, but just keep in mind, this is just a strategy that I'm trying to give you guys so you're not missing them. Go to the next page. This question right here, prime factorization. Obviously, you have to have work. Whenever I ask you for that right there, you have to show your trees. If you don't show that work, it will be incorrect. Okay. This one, volume. We haven't done a lot with volume. I think you're doing it or going to do it in science class. You just have to figure out. I'm just going to go ahead and tell you that volume. There's the formula that your science teachers are going to teach you is length times width times height. Now I do a formula that's slightly different than that, and I have my reasons. But you just have to basically go through and figure out if I have a volume of 75 feet cubed, which of these would actually give me that if I did length times width times height. So it's basically a question. You haven't learned this yet. So basically you're just going to go through here and check to see which of these equals, when you multiply them, 75 feet cubed. Notice it's cubed. Volume is cubed. Remember, area is squared. Volume is always cubed. Okay? This question, pretty easy. I mean, you can kind of see how what the pattern is. This is the first figure right here. This is the second figure. This is the third. You're kind of seeing the pattern, hopefully. So if you kept going, you could draw this out until you get to the seventh. But just think, if we skipped a couple here and we got to the seventh, what would this number be right here? It's pretty basic, I think. Okay? All right. Last couple here. These are really hard to read on mine. I'm sorry. I think they're better on your copy. But this is just that distributive property, remember. So if I gave you 18, let's do a different one. I'm just going to make one up. Let's say I did 6 plus 18. Whoops. 6 plus 18. If you were turning it into something that looked like this using the distributive property, remember the GCF is going to go here. Okay, so you would have to do your trees of 6 and 18. That would be 2 times 3. This would be 2, 9, and then 3 times 3. So you'd end up getting 2 times 3 and 2 times 3 times 3. You can see that they have a common 3 and they have a common 2. Therefore, the GCF is 6. And then we just distribute it. So we multiply the 6 times what would get me back to 6? Be 1. 6 times what would get me back to 18? 3. So that would be my answer. So up here I kind of gave you this, like this form right here, and then you had to match it up to the little tile that is the correct one. Okay? Definitely got to have work on these two. Okay, we've talked about these algebraic expressions. For instance, here's 4 plus 3x. The first step that we have to do after we've written PEMDAS, is we need to turn it into a numeric expression. I will be grading this. If you don't do this, it's wrong. Okay, it might seem picky. I don't care. I want it done this way. I've explained it several times. We're almost at the end of the first quarter. It's time to start doing it the way I want it done. I did no math. I didn't add. I didn't multiply. I just rewrote it, only I plugged in those numbers for those variables. Now we can follow PEMDAS and solve. One step rewrite, and again, you should have a tornado at the end of it. Same with this one. Here we have 4x plus 2 to the y power. Okay, notice that's to the y power. First thing I'm going to do is I'm going to turn it into a numeric expression. So it's going to now say 4 times 3, because anytime a number is touching a variable, it means multiply, plus 2, and then y would be 4, so it would be 2 to the 4th. Now I'm ready to follow PEMDAS. I'm ready to do one step and rewrite. And again, you have to have, it's going to end up being 3 more lines after this. So one line here, one line here, one line here, and then your answer. I have to see a tornado here. Okay? Got to see it. If you don't have it, it's wrong. It's that simple. It's wrong. Okay? All right. And this last one, I'm going to do one like it. Okay, so I'll do 0.291 times 14.1. Okay? So the way that I've taught you over and over here, since we're going into Chapter 3, is I have taught you just to eliminate decimals right now. So we're simply going to do 291 times 141. Get rid of the decimals. 1 times 1, we kind of go in this fashion where we kind of do this, then this, then this. So 1 times 1 is going to give me 1. 1 times 9 is 9. 1 times 2 is 2. Now I'm done with that, so I got to put my placeholder that's representing that. 4 times 1 is 4. 4 times 9, 36, carry 3. 4 times 2 is 8, plus 3 is 11. Okay, now I've got to get rid of that, and I got to get rid of my carries. Okay, now, since I have 2 cross-offs, I've got to do 2 placeholders now. Okay, so then we do 1 times 1 is 1, 1 times 9 is 9, 1 times 2 is 2. Now we're ready to add these up. 1 plus 0 is 1, 9 plus 4 is 13, 1 plus 2 is 3, plus 6 is 9, plus 1 is 10. Okay, and then 11, carry 1, 3, 4. So we know that if I were doing 291 times 141, it would equal 41,031. Okay, which means the decimal's right there. Now we've got to do that final step where we have to put that decimal back in. So that's where we're going to go to our original problem. We're going to say, okay, I got to put the decimals back in. So how many numbers to the right of the decimal did I have? I see that I had 1, 2, 3, 4. So I need to move my decimal 1, 2, 3, 4. So my answer to this would be 4.1031. So it'd be 4 and 1,331 10,000ths. Okay? Wouldn't need to see that work, but just, guys, just eliminate that decimal. Just get rid of it. Do 104 times 213. Do all that work, then stick the decimal back in at the end. Okay? Hope this helped, guys. See ya.